You've made it to the home stretch. By the end of this lesson, we'll be done creating our product file. To continue learning, let's add an event that makes use of the data parameters which we discussed previously. In our product file, for training purposes, we're going to edit both the projector on and projector off events into a single new event titled projector power. We'll add functionality of both the projector on and projector off events into this single new event. To start, let's delete the projector off event. Deleting events is just as easy as creating them. You simply click the X button when the event you are trying to delete is highlighted. Boom. Next, let's edit the event name to projector power. Description: turns on or off the projector. Now, let's make a data parameter called projector state. This parameter is what users will need to fill out as they are adding the projector power event into a sequence. The only difference between the outgoing message of the projector on and the projector off commands was using the ASCII number 1 if you were turning the projector on, and the ASCII number 0 if you were turning the projector off. Because this information is not necessarily something that the user would know, let's make it easy for them. The data parameter type we can pick for this parameter will be option. For the description of this data parameter, type select to turn on or off the projector. Example value, on with a capital O. Let's not add an initial value because we don't want this parameter to start in a specific state. Then click Configure Options. Now we can add our parameter options, what the users see, and replace them with the data that the product file needs to send the message correctly. Click plus to add the first one. Match, on with a capital O, replace with 1. Add a second one. Match, off with a capital O, replace with 0. Then close out of the pop-up window. Now that the parameter has been made, let's go use it. Switch to the Outgoing Message tab. For training purposes, let's just delete all the substrings we made earlier. Now, let's re-add the substrings. First is the constant, all the way up to the point where the 0 or 1 is. So in this example, parenthesis PWR will be our first constant substring. Next, highlight the 1 and add it as a parameter type substring. Then, we can choose the parameter power state, which we just made. Let's finish by adding the final constant section, parenthesis hex 0D. Nothing changes on the incoming response. So, instead of specifically having to pick a power on or power off event, the user will choose the power projector event, and in WinScript while adding the event, choose on or off from the drop-down menu. To finish up this example product file, let's add one additional event to demonstrate device variables. One common projector command that's useful is the getLampHours command, where you can then use that data to track active lamp hours in a projector and have WinScript make an alert if the hours get too close to the lifetime value of the lamp. This would be so maintenance could then change it out before it fails or dims too much where guests may notice. Let's make a getLampHours command. For the description, I always recommend getting detailed, as this can help the user figure out where the information ends up in WinScript Live. In our example, we want to make sure that the getLampHours event is filling a device variable named lampHours that we will shortly make. Let's enter the following information in the description box. Gets the projector's lamp hours and stores the information into the lamp hours device variable. Our sent message for the event is parenthesis SST plus lamp parenthesis hex 0D. Add it as a constant substring. Next, for the incoming message, The incoming message is sent to the controller in the format of this. It's long and a little ugly, but we only care about one portion of it really. Let's add it to the example incoming message box and start parsing. All the way up through the first parenthesis is a constant, so add your first substring as a constant. Next, the 06 is what our lamp hours variable needs to grab. Before we add it as a substring, switch over to the Device Variables tab so we can create our lamp hours device variable. You'll notice by default that there's already one device variable created named error. The error device variable is automatically set to true if any of the events in your product file do not get the expected message format back from the device you are controlling. So in our example, if the user sends the projector power command and does not receive the R hex0D response back after sending, the error variable will get ticked to true. You can then use the error variable in your script to do things such as set an alert in the live log if communication starts to fail with the device. Note, the error device variable must be manually set back to the false state in your script. That does not happen automatically. Let's add our device variable named lamp hours. So the user can use the lamp hours device variable in calculations. We want to store it as an integer instead of an ASCII string. Choose variable type integer. If we wanted to give this variable an initial value, we could do that here. That initial value will then be loaded into this device variable during our show controller's boot up process. So if you want to start your script off with a variable automatically filled with some sort of data, you could do that here. We don't want to fill this variable with any data before the show controller gets a chance to query the projector, so let's leave it blank for now. Finally, just as we left a detailed description of the event, let's leave a detailed description of what this device variable is. Lamp hours of the projector filled with the getLampHours event. Now, let's get back to our incoming response and add 06 as a substring type variable. On the right, we can then select the device variable we just made. Select lamp hours. Next, we have a bit of detail work to do. When the product file is grabbing this incoming information, the 06 is being delivered as the ASCII characters 0 and 6 in a string. Because we'll want WinScript to perform math on these characters, we don't want them to be sent into the lamp hours device variable as an ASCII string. We want them to be sent as their actual integers. So, we must use an operation. Select the operations checkbox. Next, click the Insert Function button. As you can see, there are a lot of functions you can use in Product File Creator to better massage your data before it's sent to your script. We'll want to use the A to I function, which converts ASCII numbers into usable integers. Select and click OK. The format has now been entered into the operations box. Now we just need to edit it and enter our actual data. Get rid of the string placeholder and enter the string name we want the operation to be applied to. No quotes. In this case, it's lamp hours. Finally, what if lamp hours gets over 2 digits in length? Let's adjust the maximum digit count to something other than 2. In fact, let's just get rid of it for now. Here's a good time to chat about needing to keep your regular expressions locked down as much as possible. That way the product file doesn't interpret one incoming message as a different one. Product files work by matching regular expressions to what it expects the incoming messages to be. If you have two regular expressions that are the same or could be interpreted the same way, that is not good and will cause problems with your product file. Next is the colon, which again is a constant. Next, are the ASCII numbers 4 and 5. These account for the minutes of the projector lamp readout. Since we're not interested in grabbing this information, we only care about the whole hours, we're not going to set this up as a variable. Instead, we'll set this as a wildcard, as the numbers returned here will always be different, but we don't care what they are and don't need to do anything with them. In this position of the message, the projector will also return numbers 00 through 60, so keep the minimum and maximum numbers at 2 and 2, digits only. The rest is a constant, so add it. Your work will be checked and showed up in the regular expression format result at the bottom of the tab. It shows, quote, a match, so things were done correctly from the standpoint of matching the regular expression you created to what you have typed in the example incoming message box. Save the product file, and we're complete. In the next lesson, you'll learn how to upload this product file to WinScript so you can use it in your script.